welcome back to your favorite programmer, the place where we make coding simple, fun, and exciting. If you're on a journey to ace coding interviews and level up programming skills, you are in the right place. Today, we're going to tackle an interesting coding problem. It's called toSum. Given an array of integer sums and integer target, return indices of the two numbers such that they add up to target. You may assume that each number with exactly one solution. You may not use the same element twice. You can return the answer in any order. Okay. So this is the example. So we're given an array and then this is the target. So we need to find the indices that will add up to the target. Okay. Let's say 2 plus 7 will give us 9. We cannot use certain numbers. We cannot use the same number twice. Okay. And then there's a twist here. Can you come up with an algorithm that is less than order of time complexity of O(n) square? Okay. That's two approach, guys. We can do the brute force approach, which is like we're running double loop. We're gonna try that one first, and then we're gonna try another solution, which is order of n, which is much faster time complexity. Okay, let's try the brute force one quickly, and then we can move to the other one. Okay, so the brute force is we're gonna use int arr. Okay, because we need to return the indices, new int of 2. Okay, and then we're gonna for loop int I equals 0 while I is less than nums dot length I plus plus. And then since we're using brute force, how are we gonna do? It's like we're gonna compare the target with each of the other elements. Okay, if they add up, if they add up and give the sum is equal to target, then that's the indices. Okay, that's the simple brute force way. Gonna use another for loop in j equals I plus 1. So we're not gonna start from 0 because we cannot use the same element twice. So while j is less than nums dot length j plus plus, right. And then for this we're gonna find in diff. So what's a diff? Diff is target minus nums at I. Okay, so target minus nums at I will give us the difference, so that we can, if we find the difference in the rest of the array, that means the index at j and index at I are the indices, two indices. Okay, so what are we gonna do? If diff equals nums at j, okay, that means we found the indices. We're gonna do nums okay, arr 0 equals I, and then arr of 1 equals j, and then we just break so that we don't need to run the loop, and then we can just return the AR array. Guess that will work. Oh yeah, array at 1, sorry. As you can see, we are trying with the brute force approach. Let's see the time complexity. It's 35 millisecond, which is quite not fast. So let's actually use the more efficient optimized solution. We're gonna use hash map for this. I don't know if you have used hash map, but you can try. If you don't know about integer, if you don't know about the hash map, you can just YouTube hash map of Google. Integer of map equals new hash map. Okay. So then we're gonna use array int arr so that we can return indices equals new int of size 2. Okay, we're gonna use for loop again, but only once, so that we got the time complexity of linear time complexity, which is O of n. Okay, and I equals 0 while I is less than nums dot length I plus plus. And then let's get the different first. Diff, if diff equals target minus nums at I. Okay, so target minus nums at I, it will give us the difference. So we're gonna check if we already have the difference in the hash map. Okay, so how do we gonna store the hash map? We're not gonna store index and value. We're gonna store the value first as an index or as a key, you can say, and then we're gonna store the index. Okay, so that we can do constant lookup. Hash map, if you do a lookup, it's constant. Okay, we don't need to worry about the time complexity. So if map dot contains key diff, okay, if we have the key, that means we found the indices. We just gotta do arr of 0 equals map dot get diff, and then arr of 1 equals I, and then break the loop. And then if we don't have the, if we don't contain the key, we just put the key there. So map dot put, so we're gonna put the value first, let's say like nums at I, so that we can do constant lookup, and then we're gonna store the index. Okay, so after this we can just return array. So this was the runtime first, but we do have to sacrifice some space here because let's do a run. Okay, correct. Let's submit. See, we got much better solution, guys. 2 millisecond. Okay, 2 millisecond time complexity, and space complexity, it's order of n also. So yeah, that's it for today problem. We covered how to break down the problem, plan efficient solution, and implement it by step by step. If you find this helpful, make sure to give this video a thumbs up, subscribe to your favorite channel programmer, and hit the bell icon so you don't miss one awesome coding tutorials. Let me know in the comments what's the next LeetCode problem or tech topic would you like me to tackle. Until next time, happy coding.